I thought I would be loud enough. Okay. Welcome, everyone. So it is a pleasure to have you all here at this time on this very important issue. So the title, as you all know, is Energy Crisis. Can we turn this crisis into an opportunity for energy transition, which we aim for 2050? So as the schedule is visible to you, we will have 4 speakers who will present their views 15 minutes each for initial 1 hour. Then we will have a debate moderated by Professor Dirk. So this session is also welcome everyone. So it is a pleasure to have you all here at this time on this very important issue. So the title, as you all know, is Energy Crisis. Can we turn this crisis into an opportunity for this is interesting stuff happening. Okay, so that was the delay or the lag we are familiar with. So we will start with a presentation from IEEE student branch side, which is like who facilitated this entire event, also the pizza, which we enjoyed, and the drinks. So first, I hope you enjoyed it. So first I will invite Arnaud to present the student branch, and then we will move to our presentations. Arnaud, please.
So besides the chair of IEEE branch, I'm also the photographer for tonight. But yes, thank you for the introduction.
Could you use the mic?
Yeah, mic. Sure. For the online people, yes. So as I was saying, besides a photographer, I'm also the chair of the IEEE student branch. Do we without or with? Okay. But yes, I'm very excited for tonight. I hope you as well, because besides the IEEE student branch, we also have 3 chapters. 3 technical chapters who are associated with their IEEE society. And well, as you probably know from the poster, this event is organized by the Power Energy Society. We also have the Solid State Circuit Society, and very soon, well actually it was already approved, is a joint chapter of the Antenna Propagations, Communications and the Microwave Techniques and Technology chapter. So logo is coming soon. But as IEEE student branch, we try to bridge and convey our passion on behalf of the Institutes of Electrical and Electronics Engineers to bachelor students, master students and PhDs. So as you probably know, IEEE is a very renowned institute, an organization who is known worldwide. But the fun facts are actually that there are lots of student branches and student chapters. And so I'm very proud to be part of that IEEE family or organization. But as I said, we do activities like the job fair to bring students and industry together. We do lectures or symposium, like this panel discussion, organized mainly by our technical student chapters, and also practical evenings to help bachelors to explore and tinker a bit and think about all the possibilities they can do with electronics. So our next event, I want to promote it as well already, is on the 5th of December in the Quadrivium with our next job fair, where you can see the poster. So if you visit the website, you'll find all the information on that. But we also plan to organize lunch lectures to dive into a very diverse range of topics which otherwise would not be taught in courses, but could also be relevant for students. Or organize again those practical evenings to know how to solder, to know how to connect everything in an electrical circuit, or how the grid works, or so on. And for that, actually probably that's your old office. In the entrance of ESAT, we opened this academic year, the EFAP. So there's a close collaboration with ESAT, where there's a room to complete these practical evenings. So yes, check out the website if you're interested, or contact us. You can also subscribe as a volunteer. But of course, this is the branch. But I think that Chandra can present the chapter and his team and his activities much better.
Thank you, Arnaud. Thank you very much for this introduction. So in this line, we can move to the PES Chapter team. So you can see all these faces. You must have also seen them during the reception and here. So in this T-shirt. And with this team, what we do is like these activities which we did in past. Some of the Power Symposium has been one of our consistent activities, which was interrupted by COVID, but still we did it in online mode as everything else. Then we have guest lectures and tutorials also from the visiting scholars here. Then the industrial trips, finally networking and the socialization events. So most importantly, in this slide, you can see apart from this lecture, next semester, we have many more activities coming for you. First one is the like that industrial visit, which is going to be a power plant visit somewhere in February 2023. Then lunch talks. That might be very interesting for some of you, in which like during every week, one of the PhD scholars will be presenting his topic and his work in a very informal manner. So it can be very technical as well as in very informal setup. Finally, there will be power system, not finally, but like somewhere finally in this list will be a power symposium somewhere in the April of the next year. You can stay tuned by following us on either of the two platforms. So without further delay, I will invite our speakers. Before that, I will have an announcement for our online participants. So you can type your questions in the chat. Unfortunately, we will not be able to unmute you and allow to speak because of the time constraints and other technical glitches. So all the questions will be taken at the end. So please specify your questions like whom you are directing it to. Then we move directly to the Professor William Dassler's talk. So before inviting him, I would like to present a brief bio. It is a very long bio. If I read it completely, it will be my own session. So, but just to say a few lines, as of October 1st, 2022, he is an emeritus professor at KU Leuven. So his education and industrial experience reflect multidisciplinary interest in energy and drive to understand the underlying physical phenomena and complex systems. So he received his PhD from University of Wisconsin. And before joining KU Leuven, he spent several years at the Max Planck Institute. His research interest concentrates on energy systems, energy management, and energy policy. So Professor William Dassler, floor is yours, please.
Okay, I think I'm waiting for the, yeah, okay, thank you. Some of you have already had lectures from me, so some of these things might be duplicate because I haven't changed my mind since a year ago or something like that. Now, if you look at the title, I could actually easily fill 3-4 hours with that. So my talk will be relatively superficial. We'll run through my slides like a movie, okay, just to pinpoint certain things. And we leave everything then afterwards for the discussion. And then you can ask any question that you want, as long as you do it in a polite way. Okay? So security of energy supply, hydrogen, how about nuclear power? And what can we say about the future energy transition when we look at it from the point of view of today, where we are now in an energy crisis? I'll start with security of supply. Why? Because we've learned now recently that security of supply is important. Some people had forgotten that. And it's one of these subjects that, a little bit like sustainability, it's being abused by many people, and many people use it according to their own wishes. And they only concentrate on the thing that fits their own purpose. But it has so many different dimensions, and that's what I would like to show a little bit. Okay. First, I'll start with some anecdotal things, some examples. Now, most of you were still, well, hadn't seen the light yet by that time, by 1973. Some of them on the front here, they did. Okay, that's the Middle East. That's the first oil crisis. It was war in the Middle East. Okay, and there was an embargo for the Western countries, and indeed, that was indeed a major problem. And if you look at Belgium, and these are real pictures, these were these were days where we were not allowed to, well, where one was not allowed to drive, and we actually, as kids, we were running with our bicycles on the speedways, okay? So it was that type of fun in those days. That's what happened there with that hike of the oil prices in those days. Now, something that you shouldn't, that a lot of people seem to be mistaken, it doesn't mean that you have your own things in your own territory, that necessarily it is secure. Let me give an example for domestic coal. Okay, well, in the UK, they had a major mine strike in 84, 85. It doesn't mean that you have coal mines, that you have security of supply of coal. Same thing for domestic oil. Why? How come that a country like Iran, that they are importing gasoline? They have a lot of crude oil, but they didn't have enough, especially then refineries. So you need indeed then more than just that thing. And of course then natural gas. I think you know some of these people. The 1st of January 2006, indeed Gazprom, they just closed the faucet. That's the first thing. There was a book published in 2008. For those who don't understand English, Dutch, I'm sorry. Gazprom, yeah, that you understand. Russia's new weapon, okay? Yeah, okay, I translated it there. I'm sorry. All right. So, yeah, and then, of course, the 1st of January 2009, it happened again. Yeah? So we could have learned our lesson to some extent. Now, it's much more complicated than what I'm saying, because there was a dispute with Ukraine, a commercial type of thing, whatever, okay? I'm willing to dig into that somewhat deeper later on. But yeah, and then of course, these days, after February 22, yeah, a full-fledged invasion of the Ukraine by our good friend, Vladimir. And yeah, you could say that that's not very wise if you just get most of your natural gas from one single supplier. It's much better to do it this way, where you have then a multipolar delivery. Diversification is one of the secret words that we have to use. As a matter of fact, Belgium did pretty well. It's one of the few things that we in Belgium, I'm sorry to say so, that we are doing right, or at least we did right. We have 18 entrance points, and we have indeed very well diversified. I always tell my students, and some of you have heard that, for electricity, we had everything in our own hands, and we messed it up, we screwed it up completely. For natural gas, we didn't have any gas, in contrast to our northern neighbors, and that we did actually pretty well, because we turned our weakness into a strength. And then Germany. Well, of course, I can't resist saying something. That's what I call a tunnel vision. They wanted to be clever, and they said, aha! We're not going to go there on the left-hand side with just these pipelines through Ukraine and to Belarus. We're going to have our own pipeline in the Baltic Sea there, called Nord Stream. And this was, look at 2009. Look at Mrs. Merkel, how happy she is. Look, she's looking at heaven there. Wow, if you look at all these people who, yeah, were part of the game, and they believed that that was indeed a good idea. Now, I'm overdoing this, and I know that. But okay, otherwise we won't get any questions later on. Huh? Now, then they wanted to have Nord Stream 2. And it actually is strange that Germany needed to have a war to come to their senses to realize that it wasn't the right thing that they were doing. Okay? And indeed, and at some moment then they halted the crosses at the right place, so they halted actually then Nord Stream 2, and we know now what to say about Nord Stream 1 as well. It all started then with the natural gas storage in Europe, where indeed then the bottom line there was something that was in principle then rented out to Gazprom. Okay. Fine. Electricity now. Well, electricity, if you look at this from space, look at that in August in 2003, it went black. Now, of course, what usually happens then, this was New York by night, what usually happens if something happens in the US, then the Europeans, they start laughing and they say, oh, these dumb Americans. Yeah, but look, a month later, the same thing happened in Europe. It was basically then somewhere in Switzerland, Italy, that indeed that, and this is the report that it says then, that indeed and also then Europe could go black. Rome by night, equally interesting, even close to the Vatican. Okay, now a very important thing is that, because I'm going to stress in a minute the investments, but of course, if you have invested into something, it should also be available to run. This is a picture of the availability, nuclear availability in Belgium from 2011 to 2019. If I hadn't put that on or hadn't told you that, maybe you might have thought that this was then the fluctuation of a wind turbine or something like that, but it isn't. So it is a very important thing. Something that the French have troubles with now these days is indeed that they have problems, issues with their nuclear power plants. Of course, there are all kinds of reasons that can be well explained, but the most important thing is that if you have a generic safety issue, if you standardize too much and you have a problem there, you have a problem, okay? Now, I'm going to give you now, this was all kind of to warm it up, okay? Now, a structured analysis. And here I'm going to go equally fast because some of you have already seen this. But you have to make a distinction between what I consider then, to keep it simple, in three different things. What I call the strategic security of supply, that's focusing on the primary energy sources. Adequacy, that's mostly investments. And then you have the sudden cuts and the blackouts, that's yet another level. Okay? Now, strategic security of supply, continued provision of primary fuels and sources to satisfy the request of the end consumer, given that all means exist to get the energy flux from the producer to the consumer. That's mostly looking at the producer side, if I may say so. The physical availability, well, you first have to have the endowment. If you want to have oil, you need to have oil in the underground, gas, the Netherlands, you need gas. The same thing, of course, is then also for wind, for biomass, for other things, okay? You need to have the meteorological conditions. If they take the United States in the Midwest, where they have massive possibilities for wind. But of course, having the wind itself is not enough. Later on, we will see that you also have to invest in wind turbines then, of course, to capture that thing. So you have to do, and that's what I'm saying here, so you have to invest in production capability. And that's for wind, for oil, for gas, for whatever, for hydro dams. You have to harvest and you need to harvesting capacity. And then the third thing, which also plays a very important role, it's geopolitics. And there I usually say, well, yeah. Many people had forgotten that it exists, but it still exists. Actually, one of the few authors who has spent quite some time on that in his latest books is Dan Jurgen from the United States, winner of the Pulitzer Prize, The New Map. It's actually something that is a quite interesting book. The second thing in my structured analysis, that's adequacy. That's basically, to say it simple, make sure that you build enough at sufficient time. That's looking at the consumer and the transit side. It's indeed unrelated to planning of the infrastructure. And the first thing is you have their electrical power plants, the high voltage grid, high pressure natural gas pipelines, low voltage and low pressure distribution grid, oil refineries, uranium enrichment. So you need to invest in things, otherwise you can't do anything. Also with baseload, flexibility, variability, and all these things. Transit pipelines or means, LNG ships, cross-border high voltage lines, oil tanker fleet, if you want to integrate your overall system, also investment needed. And usually you're not the boss of your own investments there because it's about transit that you're talking. Sufficient local energy storage capacity. The oil reserves, that's where the IEA came from. 90 days is obligatory to have that as a stock. Natural gas reserves has been a huge discussion in Europe since the 2000s. It was decided most often that this strategic thing is too expensive to just sit there and not to use it. Now we see that actually it may be very helpful. Electricity storage is one of the big issues, of course. We have hydro pump stations. Batteries are making quite a bit of progress, but we still are fighting that long-term energy storage. If we have a cold spell, Dunkelflaute, then we still have an issue. Okay, now what are the things that may hamper these investments? I have a whole list. I'm not going to address all of them. I've underlined a few of them, and that's what I'm actually concerned about these days. If I see what has to happen from now till 2050, getting construction permits of everything. I'm not going to mention high voltage lines. I'm not going to mention ventilus and these things, but it's a little bit everything. Whatever you want to build, people protest. Market design is another thing. When something goes wrong, when the market actually functions the way it is doing now, then politicians start to become very nervous. And they're actually thinking of changing the thing. But prices are a signal. There is a reason why the prices are high. Whatever. There are other things that I've listed here. Here at the bottom, I've also mentioned then the clogged supply lines. Of course, you may say that this is a temporary effect that was a consequence of the corona thing. But it's something that we have to keep in mind. Also, it has to do with the semiconductor chips, that most of them come from Taiwan. I don't have anything against Taiwan, but suppose that, well, whatever, okay, that there is a problem out there, that China has a particular idea of doing something with Taiwan, then I think we'll have problems. Anyway. Now, this is an important thing, and that's why I put that the two exclamation marks in yellow. The availability of invested in infrastructure. And I've actually underlined here two things to draw attention. That's if you have energy stores, so if you have enough investment in storage, you still need to look at the state of charge. If it hasn't rained for a while, then your hydro might be in problem. Also with batteries, at some moment, if you have used your battery and it's empty, well, then it's empty. Then in the middle there, the flaws in the facilities, that's indeed, and the nuclear power plants in Belgium and France. But it's not only for nuclear. In the 90s, there were problems with the Siemens CCGTs, which had kind of trembling. They were vibrating all the time. That was a flaw that was typical there. Also, Horns Ref, I think, in Denmark, at some moment they had to replace all the transformers, I recall, at some moment. So it is something that you have to keep in mind. Okay, there's also the way, of course, you could say, yeah, you have to look at the load management, etc., but I'm going to skip that in the interest of time. You can read it because I make my slides available. You can read them if you want to. Okay? Finally, then, there is then the sudden cuts or the blackouts. That's a completely different thing. It's on a very much shorter time scale. And the whole idea is that you have to design your system so that it is able to absorb perturbations. That's the idea. Because perturbations will occur, will happen. Okay, so these things are expected. And you need to design your system that it has the capacity to absorb these transient dynamics mishaps. You can do that, that's the issue of security or reliability. Redundancy is a very important role. In the old days we said N-1, but if you have so many wind turbines, etc., what can you still say about N-? Well, it's a different game now at this moment. You have to, in any case, you have to invest sufficiently, and there might be many, many correlated events in this case. Maintenance, control strategies are very important. There's also then the issue of resilience. That's a different thing a little bit. I'm not going to go into detail. There is here, IEEE has spent a document on it. You can download it. It's, I think it's for free available, at least if you're here at the university. There's also an interesting blog here by Michael Riebereich. It's also well done. So you can click on it if you want to, and it's interesting reading. Now you might say, okay, I've just spent time on the physical security of energy supply, but what does it mean if the energy is available at skyrocketing high prices? Can we still say that that is security of energy supply? I've taken some pictures here from the CREG. They're not very recent. They're from, I think, this is from May 2019. And that's from February 22, so just when Vladimir already decided to invade Ukraine. Look at the scales. The scales are completely different. Same thing, as a matter of fact, for natural gas. This was May 2019. That's February. Now the things are a little bit different now, but these were things, the prices were just unheard of. Okay, so that's the takeaways for security of energy supply. It has different meanings, different dimensions, and you have to look at the whole picture before you can make a decision. You have to say exactly what aspect you're looking at, and what is the relationship of physical security of supply and affordability. That's all I'm going to say about security of supply. Hydrogen. By many, it's considered to be the solution of the future. Well, first of all, I would say this is the current picture of the amount of hydrogen that is being used. You can actually see that most of it is for refining, that for ammonia, and that's some other things. It blows quite a bit of CO2 into the air. And here I would say the sensible thing would be, first and foremost, try to decarbonize this industrial load for hydrogen. That's the most important, that's the priority. When I say that, many people, what they say, 5 minutes? Oh, 1 minute, okay. Well, I can't read very well. Now, some people compare it then to this Swiss knife that you can do everything with hydrogen. Don't believe it. Of course, you can do many things, but it isn't always the most efficient thing. And that's something I stole them from Liebreich, his so-called hydrogen ladder, where he then ranked the whole thing and then effectively says, look, at the bottom here, you can forget it because hydrogen will be uncompetitive and mostly you can do it directly with electrification. It's just near the top that you have a few of them where hydrogen might be part of the game. Nuclear power, let me say a few words about that. I'm just going to refer you to two documents which are quite well written by the International Energy Agency. The first one is 3 years ago, 2.5 years ago in May 2019, and they have a follow-up which is then quite recently. So if you want to read it, I would say Google them, they're for free available. Right? Let me just say a few words. Now, nuclear generation will be used in some countries and not in others. So it's a political decision of certain countries. However, you might say, well, okay, if we don't want them, that's not our business. But if you're living or if you are thinking of an integrated electricity market, then you will have to deal with that. Then coexistence of nuclear and the variable renewables must be addressed with the whole issue of flexibility. You always have to distinguish between the existing safe reactors. That's the issue of long-term operation. And there the issue is, if you have a safe plant, is it justified or wise or whatever to shut it down? That's the political lifetime constraint, as a matter of fact. And then you have the other thing, which is a completely different thing, that's new build. Some are still thinking of having new build big units, okay? Others are thinking more of generation 4 or SMRs, the small and modular reactors. It seems to be like also one of these holy solutions. Well, the issue will be, I would say, it's up to the nuclear society to prove their case. Okay, they have to make sure that they can construct and build safe and cheap, I think quotation marks, units. But you have to look at the overall system cost, which is not always easy to evaluate to see whether it suits or not, what the value is of these nuclear power plants if you want to build them. Also, at the bottom line, I'm not forgetting the availability of existing and new invested-in plants, standardization and generic flaws. And you have to have fair competitive markets to allow the best technologies, and I actually don't care. I'm not married to nuclear. The only thing is that I don't always exclude nuclear a priori, okay? But it's up to nuclear to prove its case, right, in the generation mix. I'll just address one more thing, 2 slides. That's, how about the future energy transition? We are in a crisis, we are in the shit, if I may say so at this moment. Sorry about the wording. This document, I would actually recommend this document. It's actually very well written. I think they did a pretty good job. Also, if you find the time to listen to their presentation, it's about 1 hour. It's well done. It's now the 3rd year that it is for free available on the web, so you can download it. So Google it and you can download it. I've stolen a bunch of their slides. I'm just going to skip many of these things. You can all read them if you want to. It's because of constraints of time, but the conclusion, I think, is quite important, and that's just this thing. I'm not going to read it. It's this one. But let's look at the blue thing. That is, it might be strange. We are in a crisis. It's a complex situation. Very few people are willing to believe it, but it might be an opportunity. That indeed everybody now is realizing that we were doing it the wrong way. We can no longer rely too long on fossil fuels, and as a matter of fact, even natural gas, where we thought that that was going to be the bridge fuel. It still will be important as a fuel, but not in the same way as we thought a few years ago. What I'm seeing, and that is on the other slides, there are massive investments that are taking place, and that people expect that this will continue in the future, that this might be even something to accelerate the transition, and that the negative tone that we heard in Egypt last week, that as a matter of fact, for me, this is a little bit of sunshine that is shining there. If we continue to do, well, technically it's something, it's a non-linear process, it's going to feed upon itself. I think we might well be better off, and I'm sorry to say that for the Ukrainian people, but what Russia did, I think it's a major change in the overall energy transition, and it might in the end be a positive outcome for energy. Let me leave it at that, okay?
Thank you, Professor William, for presenting very interesting perspective on security of the supply. And this can be a very good starting point for our next speaker, who is from the industry. And he will present the industry's view, how industry look at it, and what are their messages and opportunities. So our next speaker is Dr. Francois Boislet from NG. He started his career in 1999 at Delft University of Technology in the Netherlands, in collaboration the University of Paris, Dauphine, where he received his PhD on the topic of electricity power exchange. Francois joined NG in 2007, where he led the team responsible for energy market analysis and economic analysis of the commitment files. Since 2019, he is chief economist, part of the Regulatory and Public Affairs Department of NG Benelux, focusing on the energy transition. So please welcome Dr. Francois Boislet.
Sure. It's the other way around.
Sorry.
It's okay. Maybe. Well, you can already see I'm not an engineer. When it's technical, I'm a bit lost. So first of all, thank you very much for inviting me here. It's a pleasure for me to be here. You are absolutely welcome to ask any nasty question, but I have one request. Please don't give me the result of the game of France who is playing right now. And thank you for the invitation during the first game of France. It's always a pleasure to be here instead of watching my favorite team. Anyway, it's also a pleasure to present after a professor, because actually you said more than 80% of the thing I wanted to say, so I can focus really on a couple of stuff that I want to share with you. So, if it works. It's off. Okay. So first question is, do we have an issue? And if you look on the left-hand side, oh, sorry. Basically, that's the energy consumption for more than 60 years. And do we have an issue? I guess we do. If you look at the fossil fuel, coal, oil, and natural gas, you see that our consumption has been quite increasing. And we have a lot of discussion on renewables, on nuclear. But as you can see, the real issue is not there for now. And when I've been asked, is it an opportunity? Forget the crisis for a moment. But when you look at this, I see personally a huge opportunity for anyone interested in decarbonization. This is a challenge we have to face in the years to come. I've been working on it for a few years now. My company is working on it, and I guess this will be our work for 30 years at least. And if you guys have any skills and any interests in this area, this is the opportunity I see to remove this and get rid of all those fossil fuel, which are basically the source of CO2 we want to get rid of. If I look at the world before, and I'm trying to make a long story short, we used to have cheap fossil fuels. And since we had cheap fossil fuels, we use them a lot worldwide. It's not only Europe, it's worldwide that we use them. And we have a lot of CO2. We had renewables and low carbon sources that were quite expensive compared to fossil fuel. So we had to subsidize them, or simply we did not invest in them. And we had limited investment and demand response. Very simple example is, for instance, insulation of building. I did not check the building here at the university, but I'm not sure you are state-of-the-art in terms of insulation. And I can tell you, when I walk around in Brussels, in Ghent, or in Antwerp, we don't have state-of-the-art building. Double glazing, which has been invented almost 50 years ago, has not yet arrived in all buildings. What do we have now? Following the crisis, we do have expensive fossil fuel. So using fossil fuel is expensive. Emitting CO2 is expensive. Renewables are extremely competitive. Actually, if you want to install some PV panels today, even in Belgium, where you hardly have any sun, you do have some, but it's not Corsica or Dubai. Actually, Qatar, because this is quite popular. I'm just thinking of it now. No, it's definitely competitive, and you can get your investment back in 2 years, 3 years. It used to be 10 years, 5 years maybe with some subsidies, but right now it's extremely competitive, and you have strong incentive for investment. And you see people investing in insulation, in PV, changing their boilers. Actually, if you try to get someone to install some PV panels, you may have to wait 1 year or more because they are simply too busy. And the same thing, for instance, with heating, where you see everyone saying, oh, I'm not starting my heating yet because it's too expensive, but this has a positive impact on the demand side. So when I look at this, and that's where this all sounds good to me, and that's where you think, wow, economists are really crazy people. We are in a terrible crisis, and all those elements sounds good to him. So before I start to look at the story behind it, I just want to make sure that we have a clear diagnostic of the situation. So in 2-3 slides, I just want to explain the situation we are facing right now. So we have first a gas crisis. It was already mentioned by the previous speaker. We have less Russian gas, so you see we have less and less gas. It used to be 40% of gas supply in Europe. We are below 5% right now. I will not go into all the details of what has happened in Russia and Ukraine. As an economist, it's very straightforward. Prices have been moving up like crazy. We have been for years at price around 20 euros. We have been moving up to more than 200 euros, so you multiply it by 10. So we have been living in a world of very low gas prices for more than a decade. And with this lack of supply, or this change in the supply structure, we have seen price increasing quite dramatically. And then one important element with these high gas prices is destruction of demand. Again, I know I'm in a school of engineers, but I'm sure you have seen this basic graph of supply and demand. And that's quite dramatic. Huh? We have seen industrial gas demand, because when we think of gas demand, you may think of gas power plant, you may think of the gas boiler you have at home, but you also have to think that the industry is a large user of gas. And we have seen in many countries a strong reduction of demand. Simply with those gas prices, it's not competitive for some industry to produce what they are used to produce. So they have been reducing their demand, selling their gas, potentially making some money on selling their gas on the market. Some gas they did buy a few years ago at lower prices, but in the short term, they have to reduce their activities. There is one exception, and this is this orange line, is that we still use a lot of gas in power plant. And that's quite confusing because you have high gas prices and we still use a lot of gas for power plant. Here you've got the range of utilization of gas demand for power plant. And you see for the different years between 2016 and 2021, we were in this funnel. And you can see that we are really on the high side of gas demand. And that's a bit counterintuitive in a world where gas prices are high. And this is where I come to my second point. On top of this gas crisis, we have a power crisis. And this power crisis, you can see it on the power prices. You have been using the graph with the scales. My only difference here, I start in 2008. So I have more than 14 years of prices. And we used to have a graph with a scale which was up to 100. And we had some price close to 100 in 2008. And that was a very high price at that time. As you can see, this 100 euro, almost 100, is not a high price anymore. We used to have price around between 40 and 60 euros for almost 10 years, a bit above 50, a bit below 50. And then we have the start of our crisis. Actually, the crisis has three main elements. First one, of course, is a gas price. So basically, your gas crisis is impacting your power sector. When you have to run gas power plant, you are paying your gas price higher, so it has an impact on price. But on top of that, and it was already mentioned also, if you look at the change in the EU generation mix between the 8 first months of 22 and the 8 first months of 21, and now it's still the same picture, we have lost a lot of nuclear. This is, you find it in the newspaper. I mean, basically half of the French nuclear power plant are out. But also, and this is something you don't read so much, we lost the equivalent in hydro. We basically had a very dry year. It was nice in terms of weather, but in terms of hydro condition, it has been quite terrible all over Europe. So all the hydropowers that we are used to produce, we lost a significant part. So to compensate that, we are running on hard coal and lignite, so which is not very nice from a CO2 perspective. We are also adding some gas. And luckily, we are also using more renewables. We cannot say that 22 was better in terms of sun, maybe a bit better in terms of sun, not better in terms of wind, but since we have been installing a lot of new capacity, the delta is quite positive. So it's very important when we look at the current crisis to see those three elements: gas prices, gas crisis. On top of that, a power crisis with nuclear and hydro condition. So I could not resist to talk about the market because you see it a lot in the newspaper, policymakers, I mean Boris Johnson, Emmanuel Macron, Ursula von der Leyen, all saying market does not work. We should get rid of this market, things are going wrong. So I could not resist to play the advocate of the devil. Is the market functioning? I would like to say yes, but. Or actually the usual answer of economists is it depends. But I would say here, yes, I mean, the high prices, as we have seen in the previous slide, are the result of supply and demand condition. We lost some gas, we have issue with nuclear, we have issue with hydro, the supply is lower. Those high prices are triggering demand reduction. And this is a good thing, this is what you expect. I mean, you cannot replace 40% of supply overnight. You can replace it a bit here and there. We have been doing it. You see some LNG coming from the US, for instance. You see some nice contract coming from Qatar. Qatar again. You see this coming, but you also need demand reduction. Actually, that's the first type of policy measures that have been put forward by the EU to reduce demand, which is obviously a very straightforward way to reduce prices and to reduce the bill of customers. This is triggering investment, at least small and short-term investment. I'm giving the example of PV and in insulation. It's a bit of different story for industrial investment. You cannot do industrial investment overnight. those investments take 2, 3, 4, 5 years. So even if you decide right now, you will not get new LNG terminals or you will not get new boats or whatsoever within a few months, and this will not help you, let's say, in the short term, but of course it will have an impact over the long term. And also something which is not so important for many people, but it's critical from an economic perspective, is that all those high prices are making previously subsidized technology competitive. And actually, in many countries where the support mechanism of renewable have been well designed, actually governments are getting back some monies from their different renewable scheme simply because they are competitive. But there is a but. The extent of the supply shock is enormous. So we have a volatility which is extreme. From one day to the other, we see price, and even within a day, moving by 20, 30 euros. I like the example of gas prices. They used to be around 20 euros per megawatt hour. Now we have on a single day a volatility above 20 euros per megawatt hour. So that's the overall price of the previous period, which is the volatility we see on a single day. The system is slow to adapt, and that's a critical element in energy. You have to think of it over 20, 30, 50 years. The system we have now is also a legacy of stuff which have been built 10, 20, 40 years ago, and even more in some cases. It takes time to change it, and that's why we often talk about energy transition, because you will not do it overnight. The key point is this one, for me, is the ability for customers to pay and to be financially viable in this short period. We see it at all levels. Of course, in the newspaper, and I guess you also get some bills from your favorite energy supplier and you're not very happy about it. But you simply have people that cannot afford it. And it's not only household, you see it in small companies, medium-sized companies, and large industrials. If it's only a couple of months, and if government takes good measure, they may survive, and then hopefully after the crisis, they may be back. The issue is whether some of them will not survive the crisis. We have an issue also with respect to international competition. I mean, my American colleagues are complaining because gas prices have been doubling in the US, moving from 10 to 20. We are complaining because prices have been moving from 20 to 200. But still, even if my colleagues in the US are complaining because prices have been doubling, still, if you look at Europe and the US, prices are way lower there. And if you are considering investment in some big factories, this can be a key element, and that's an issue for Europe as a whole to see whether they could attract investment in the long term. Political intervention is essential, but it has to be good political intervention. And I could give a couple of examples. And in some cases, it's adding uncertainty. If you read the newspaper, and it's not only about Belgium, you can read them in any countries, every day you have announcement, we should do this, we should do that, I have the solution. And actually, there is a lot of noise, but in terms of implementation and the decision, some are not taken, and so some of the decisions that are taken are maybe not very helpful. So I'm almost there. So some short-term measures are needed, and there are discussion on medium long-term, and that's also a key issue in energy, those time horizon, what you can do in the short term, what you can do in the long term. I personally believe that there is no quick fix, no silver bullet. That several structural issues that were there before the crisis will remain, and I will give you some example. If I think you ask me about an industry perspective, if I try in a nutshell to explain you our approach, we try to say, okay, start with energy efficiency. Can you reduce energy consumption? Can you improve the energy performance? Whatever you are, a small customer, a university, or big industrials, that's a big element. You know, the usual thing saying the cheapest energy is the one you don't consume. That's a bit silly to say that, but that's very important. And we see that in many processes, in many buildings, many type of activities, energy efficiency is not there. Then you should go for electrification. And you have plenty of engineers here that can explain you better than I, or you can improve efficiency by electrification of some processes. Obviously, you want to do it based on renewables or low carbon electricity. And for the process, you cannot, let's say, electrify, and I come back to your ladder of Liebrich. You can use different type of green gases, biomethane, green hydrogen, blue hydrogen, whatsoever. There are some processes that you cannot electrify, or at least not with the current technologies. So this is where you could use these technologies. So just to give you a concrete example, if you look at the crisis, and you mention it, and that's very important, you hear every day we need to accelerate. We would be in a better position if we would have more renewable. In practice, from an industrial perspective, you can see any developer of renewable in Europe complaining about permitting. And permitting is about everything. Here is renewables. I mean, when you think about it, wind farms are quite straightforward. Technically, it's not very complex. But it takes 6-8 years to have a project running, simply because the permitting process, the appeal process, takes ages. And this is slowing down the investment and the decision. And it's true for wind, it's true also for solar, and for any infrastructure. And we will not talk about Ventilus, because we don't talk about Ventilus. Hydrogen, you mentioned it. We do have a strategy in Belgium. We have been updating this strategy, so that's a good thing that we have this. Still, from my perspective, you can look at it like the glass is half full or half empty. And when I look at the half empty part, because I have limited time, we need some industrial policy. It's good to have a vision, but we need to have an industrial policy on how we are going to implement that. There are some plans on infrastructure, which is a good thing, but there is limited view on supply and demand. What kind of supply? We know we want to import, great, but do we want to produce locally? Not really, according to the current strategy. And in terms of demand, that's also the ladder you mentioned, which kind of demand you want to decarbonize. Existing demand, so basically where hydrogen is a feedstock, or new demand where basically you want to use hydrogen as an energy vector to replace something more polluting. Local production, Belgium is one of the few countries with limited ambition in terms of local production. I would say extremely limited ambition. They want to import from different places around the world. The availability of renewable is absolutely critical, and we know that in Belgium we are not very rich in terms of renewable potential. And one basic element, very technical one, is certification. How do you certify that your hydrogen is really green or low carbon? And if you want to import it from different countries, you really need to work on that. So if I share with you some personal view, so the crisis is definitely reinforcing all the economic incentive for decarbonization. So you mentioned that it could be a good thing in the long term. We know that in short term it's quite terrible, obviously, for the people living in Ukraine and for any customer in Europe receiving their bill. It's seriously increasing the awareness on our fossil fuel addiction, because we claim all the time we want to get rid of fossil fuel, but we see that when we remove fossil fuel, we have an issue. I compare it to people who want to stop to smoke, and then you remove their cigarette, and then they don't feel so good about it. The importance of diversification, you mentioned the German case. It was not very high on the agenda, diversification. We have been talking a lot about price, about CO2, but diversification was not very high on the agenda. And it's true that diversification comes at a cost. Because if you use different sources, economically there is one which is cheaper than the other. If you diversify, it's slightly more expensive, or could be way more expensive, but it's more robust. It's questioning the role of market and regulation. This is where, as an economist, I'm having a lot of fun, because sometimes you feel that markets are terrible and regulation is wonderful. We like this game between market and regulation a lot. It's pushing for acceleration. Everyone is claiming we should accelerate. So this is where I see the huge opportunities. The issues are, first one, if you have to remember one, is really how to survive in the short term. You can think of customer, obviously, but also suppliers. If when you are a supplier, and sometimes people ask me, but you should be happy as a supplier with those high prices. We are not very happy, to be honest. Why? Because with this volatility, the risk we have are pretty high. And I prefer to sell electricity to people at 50 euros and they pay their bill than selling it to them at 200 or 300 euros and they don't pay their bill. So we see a lot of issues, and we see suppliers going bust in many places. We should avoid panic football. I still have this football in mind. But finger pointing, when you have a crisis, you see that the because of politicians, that's because of companies, that's because of Russia, it's a mix of different things. And I see a lot of over-promising by policymakers. You see people saying, yeah, we will solve this, and you will not feel any pain. Investing in a volatile environment is not easy. You could say, look, these prices are wonderful, 600 euros per megawatt hour for electricity. You should be investing like crazy. But no serious investor will take this price as a price for the 10, 20 years to come. So when you have huge volatility, it creates also big uncertainty. So when you plan long-term investment, large investment, it's an issue to have such a volatility. And the issue is really to make this acceleration a reality. Thanks a lot.
Thank you, Dr. Francois, for presenting industry's perspective on the issue, on the crisis. With this, we would like to invite our next speaker, Dr. Peter Wingerhout, who will be presenting how research institutes look at this opportunity. Dr. Peter Wingerhout received his master's in 2006 and his PhD in nuclear physics in 2011. Since then, he worked at KU Leuven and Energieville as a project manager in the field of smart grid technologies and related applications. Currently, he's expert energy and climate strategy at Vito Energieville. So please welcome Dr. Peter Wingerhout.
I will just hold it. Yeah. I have one comment to your presentation, Francois. Don't check your phone. What is your opinion on the nuclear power plants and the exit of nuclear power in Belgium? That's the first question I always get when I tell somebody I work in the energy sector. There's very few exceptions. Recently we did a study at Energieville. I will tell you about that study. But first of all, I want an introductory slide to show you that the challenge is much broader than only these nuclear power plants, and you don't have a view on the energy sector if you have an opinion on the nuclear exit in Belgium. To the left, you see percentual emissions in Belgium in 2020 from klimaat.be. And to the right, I summarized a few key numbers that I think you should be remembering if you look at energy as a whole and energy debates. If you look to the press, they try to dumb it down. You always see football fields of solar panels and power for so much families, which is a terrible metric because you need power also for industry and for transport and for other applications. So a few key numbers here. Belgium, you have 420 terawatt hours final energy consumption, of which 84 terawatt hours is electricity. So electricity production is only a fifth of the total final energy consumption. What is the rest? We have the industry, the molecules, natural gas that is needed in industry and so on. You have transport, the diesel and gasolines in our cars. You have the gas boilers and the heating oil boilers in the residential and commercial sector. You have the agricultural emissions, of which part of the emissions are not CO2, but also methane. For example, cows emitting methane. There's quite a lot of sources of emissions, and electricity production is only a part of the problem. You also have final non-energy consumption. I don't know if you know what that is. I see a few people nodding. Of course, you're kind of an expert audience. For example, in the steel sector, when they want to turn iron oxide into iron, they use coal. And the carbon, it takes away the oxygen from the iron, and CO2 is emitted without burning the coal for energy. That's what they call non-energy emissions. Very few people know this, but it's quite large percentage of the energy balance. So this is a bit of the overview in Belgium, and I also added a few numbers in Europe, and I think 11,000 terawatt hours of final energy consumption is, and 205 2,500 terawatt hours of electricity consumption. These are the order of magnitudes to keep in mind. Let's go to a few quotes of the news this year. We have an energy crisis. Energy is all over the media, and you see a lot of different discussions. Let's go to a few quotes and see if they're true or false. It's quite fun. First of all, Germany closed their nuclear power plants. They had 12% of the electricity production, but now they had a 12% dependency on Russian gas. So without the nuclear exit in Germany, there wouldn't have been a problem. Is that true or false? I think you hear me coming. This is false. Only 6% of gas in Germany is used in electricity-only plants, 14% if you count CHPs as well, but CHPs, combined heat and power, you cannot easily switch for nuclear power plants. So most of the gas is used in industry. And if you think this is a fictive example, this was actually said by a Belgian minister on primetime TV. I think it was an information program called The Afspraak. So it's actually been said uncontested on primetime TV. Second quote, nuclear contributes 14% to the primary EU energy supply and wind only 2%. Is that correct? Well, that's actually a correct quote. But this is primary energy supply, which means the energy content of the fuel. Of course, if you compare wind and nuclear, it's much more fair to compare the electricity they produce. So while the quote is correct, you can tweak what, depending on the point you want to make if you talk into primary and final energy consumption. And I think this is also, if you look at energy debates and you watch it critically, something to take into account. And finally, a hydrogen bus on green hydrogen saves, and I made a calculation, 68 ton CO2 a year. Quotes like this you also see all the time into the media. And it is false, and I would say it's false. It depends what you refer to, but I would say, in Belgium at least, this is false. First of all, where is the hydrogen coming from? If you say, my hydrogen bus saves emissions, green hydrogen with electrolysis, you need to produce it from electricity, and the emission intensity from your electricity also counts. If you're neglecting that, then you're making not a correct point. Secondly, so hydrogen, firstly, hydrogen is not an energy source, it's an energy carrier. You need to produce it. And secondly, you also don't need to compare only with the fossil fuel alternative, which is a diesel bus, but also with upcoming electrical buses. In the Netherlands, most of buses that are sold are today already electric. Belgium is there a little bit behind our northern neighbors. A lot of these quotes, if you watch television debates on the energy crisis, you can check for yourself in the energy balance. It's actually one big Excel sheet which contains all fuels that are used in all kinds of sectors and all quantities, and it's one Excel sheet. And if you check it, you can already go on Twitter and correct the politicians on false information, because these things happen more than you think. So, we are in an energy crisis. We need to go to a climate neutral, net zero emission society in 2050 in Belgium. How do we do this? This is a schematic, very simplified schematic of the times model we used at Vito Energyville to model the path up to 2050. What we basically do is we need services by society in 2050. You see it to the right here. Industrial products, you need steel, you need chemical products, all kinds, you need cement, you need zinc, copper, so on. Transport, freight kilometers, transport, person transport. In the residential and commercial sector, you need heating, you need electricity, you need agricultural products. And what we do is we take all the processes that can deliver those services to society. Nuclear power plants, gas power plants, all kind of power plants, wind, solar power plants, storage, combined heat and power, refineries, different types of transport modi, import of molecules, import of electricity in Belgium, all kind of processes that deliver those services, renovation as well, all kinds of processes that you can think of, and we put it in one big cost optimization from now until 2050. And this yields not what I will show in the next slides quickly through the sectors, what our model calculates to be optimal, and you should see the results not as something that will happen. It's not a prediction of the future. It's something what should ideally happen if we follow the cost optimal path towards net zero society. So this is a bit more information on all the industrial processes to model, just to show you there's a few thousands of processes possible that, that can be delivering those services I talked about. What we did with this model, we didn't have one run because there are some things, some assumptions that are subject to uncertainty. We have a fairly good idea about the cost drop that has been with wind and solar energy and which can expect it later. But for some innovative technologies, it's difficult to estimate, will they be a breakthrough? Will they deliver on their cost promises in the future, and so on. So you need to make assumptions, which is what we call scenarios. In the central scenarios, we had 3 scenarios in the energyville study. In the central scenarios, we assumed that industrial production was stable in Belgium. This is an external assumption. It's also possible, and it's very much possible, that a lot of industry will be disappearing from this region towards what they call renewable superpowers like Chile, like Morocco, like the Middle East, where you have a decent wind and a lot of sun, and energy will be structurally cheaper. This is explicitly what we didn't assume. We had potentials for renewable energy, for PV. We had the possibility of CO2 capture and storage, and the plausible assumptions are also in the central scenario. And then in the electrification scenario, we said, what if we have additional access to offshore wind, and what if you can invest in nuclear power in 2045, starting from 2045, new innovative small modular reactor, which is an assumption because they're not there on a commercial scale, so it's an assumption. And third, we said, what if we have very cheap access to imported hydrogen on the first hand, but the access to CO2 storage is limited. And this is also an assumption which is important because for CO2 storage, Belgium has to rely on cooperation with other member states and parts of the North Sea. So these are the 3 big storylines which will come back in the rest of my slides. Now I will very quickly go through the sectors and tell you what is happening. Please also check the website. It's on the first slide of my presentation, and have a look for yourself. So first, the final energy demand, this 400 and something terawatt hours, which I've been mentioning, what happens with it? The final energy demand decreases by a third, but the electricity demand more than doubles in the scenarios, in all scenarios basically. We thought to see some differences in the molecule scenario, that there was higher for hydrogen, but at least a lot of electricity is in all scenarios. And this is even without the international, intercontinental shipping and aviation. So you need, overall, the energy demand will decrease, but you need more and more electricity. The reason for it, because heat pumps are more efficient than boilers, and in general also in the transport sector, electric alternatives are more efficient, so they are more readily selected by the cost optimization. In the residential and commercial sector, we see a very large uptake of heat pumps. As I said, this is not a prediction of the future, but what should happen. 5 years ago, if you would put a heat pump in your house, I was already advertising it to my friends, but you were a fool if you would do it. Because in Belgium, nowhere the gas to electricity ratio was so low than in Belgium, and it was much cheaper to just to heat with gas. But in fact, you see a very large uptake of heat pumps in the residential environment, combined with some district heating. In some areas, some heavily populated areas with a high energy demand, you have district heating can be interesting. What's the advantage is that you can valorize waste heat sources from industry which would otherwise be vented into the air. For example, it's a distinct possibility that in 2050 Antwerp, close to the harbor, there are quite some district heating grids there. And also distributed heating, for example, a data center or a water purification station, those have excess heat that can be valorized. So that's what should happen in the residential and commercial environment. In transport, we see by 2030 a very strong uptake of electric vehicles and light-duty vehicles electricity. The uptake of heavy-duty vehicles, trucks and so is later and happens by 2050 if you go to a full net zero emission society. Note that we don't see a role for hydrogen in the road transport. We see it fully electrifying. There are challenges in terms of charging. There are challenges still in terms of reducing the weight and the volume of the batteries. There are innovations happening. But if you let the model economically decide what is happening, it's electricity if possible, and then only hydrogen if you must. Where hydrogen is a possibility is, for example, with off-road traffic, such as bulldozers and so on. That's possible that there are outside conditions which are easy to charge, but that's only a very small part. 5 minutes? 1 minute. Oh, yes. Industrial energy use, also very strong electrification. And then I will switch to hydrogen. What happens to hydrogen? Well, we have, before 2030, we don't see a very large uptake of green hydrogen. Why is that? Because green hydrogen needs electricity to produce, and there is no excess electricity in this area. So we need first to install enough electricity sources before the uptake of hydrogen. And this is also a remarkable result because the European Commission is pushing hard on upscaling green hydrogen production. But techno-economically, we don't see it in the model. Do we reach the 2030 targets? Well, that's difficult. They're approaching very fast. In our model, the 2030 targets can be reached with a large uptake of CO2 capture and storage. However, there are a few buts. There is no infrastructure yet for CO2 capture and storage, very few. There's a startup projects, yes. Also the permitting procedures, you've seen 8 years in the presentation of François, and imagine how close 2030 is from an investment standpoint. So reaching the 2030 targets in our models, yes. In real life, let's keep that for the debate. And then finally, I want to give you an image of modeling the EPOC project. What we do in the EPOC project, we link what I've shown you, this investment model, times investment model, we link that to other types of models. Building renovation models, the entire building stock, what's the solutions, where to apply district heating, how should the heating be dimensioned, what should be the route of the district heating, transport models, how to displace, how to deliver the transport services needed, adequacy, so not only from an investment standpoint, but what if a power plant fails? Do you have enough power without having outages? How do you dispatch storage sources? Security of supply, what if components of the grid fail? How should your flows go? Market models, we were establishing a capacity remuneration mechanism in Belgium, which is a capacity form of market. So there are different market structures. You can also have agent-based models. So there's a lot of energy system models that still require developing. Hey, you are all engineers, so I think some of you will want to build things, but But if you learn to build things, you solve small problems. If you learn to model things, you can solve big problems. And so what should we do? In the coming 2 years, we should save energy, especially gas, and target support schemes to those who need it. And I'm here with a subsidized fossil fuel car. I have an analog meter at home which is turning back, so society pays my electricity bill. I got €100 reduction on my energy bill, and I got a VAT reduction on my energy bill, and I don't need any of that. I did also get a nice slice of pizza. That was nice, thank you. Towards 2030, we need to install renewables as fast as possible, facilitate the uptake of heat pumps, of infrastructure, and so on, and the permitting procedure is very important there. And towards 2050, you have several innovations that can come along, but also there, the uncertainties are still quite high. All right, I'll leave it at that. Thank you.
Thank you, Dr. Peter. So with this perspective from industry and academia, now we have our last speaker from policymaking side, how a policymaker sees at this crisis and what are the opportunities. So tonight we have Mr. Jans Hensmans from Ford Economy SPF. So he will be presenting policies for the future of energy in Europe and Belgium. Dr. Jan is advisor external relations of the unit strategic coordination and external relations at the Belgian Energy Public Service Economy, SME, self-employed and energy, Directorate General Energy. So, Mr. Jan, the floor is yours. Thank you.
Thank you. It's this one.
Yeah. Can you please keep in the
Yeah. Just tell me when to stop. Okay. I'm here for the boring part. I apologize for that. So no, that's not my. Those are not my slides. I will tell something about policy, where we try to do the things right. And as you already heard, we have sometimes ministers that don't say the right things. We often have ministers that don't say the right things. We also often have people telling us what we should do. I get calls every day and mails every day on how to solve the energy crisis. But let me start by saying, and that's an even older man than Professor Dazeleer has said, Winston Churchill said, when they started to build the United Nations, he said, never let a good crisis go to waste. And that's exactly, and I'm very glad that Professor Dazeleer has given other examples also, because this has led to something very good that now maybe doesn't work that good as it should work, is the United Nations. But let's not forget, even Russia is still in the United Nations, although they're an aggressive country towards Ukraine. But that says something. That's very important to keep in mind. Also, we have had a lot of crises before where we didn't take the opportunity. We already had, like Professor Dazeleer already said also, we already had a Ukraine crisis where some of the countries, like Italy, were dependent 100% of Russian gas and didn't get any gas, where Bulgaria, Romania, other countries, and I can tell you it was not a winter like now. It was a very harsh winter, and it's for months they didn't get any gas. Did you learn something from that? I am very truthful to you. No, we did not. So it's time we learn something about that. I must tell you that I'm talking from the federal government in Belgium, and those of you are not Belgians, but I guess you have learned something already about the federal, no? Simple things like yeah, yeah, okay, yeah. So we have a federal structure in Belgium, which means that you have regions, regions, and And I am basically going to talk about the federal competences, which is the, well, not so much nuclear, but nuclear is one of the competences. Big pipelines is one of the competences, transmission lines. But, and that's where I will focus the most on, is offshore. Offshore is Belgian, is federal. All the rest is a little bit like prices are divided also between federal and regional. By the way, when I came over here, I just heard that the European Commission has published a paper on maximum prices. So I'm looking forward to after this, but I'll stay, you know, to after this go and have a quick look on what the Commission is now finally proposing on maximum prices, and also what our countries, our neighboring countries are going to say to that, because I know if I look to the north, they are not going to agree to that, and if I look to the south, they are basically going to say that we don't go far enough. So that's the world we are living in, and we are trying to work together. So people tend to ask me, did Europe react good to the crisis? Then it's yes and no. It's yes, because it was rather quick. We have taken some measures. If you say no, it's still too divided. But then I also give the example, when I sit in European meetings, we sit at the corner always, Belgium, first country, Belgium, and then next to me sits Bulgaria. And I can tell you that guy next to me, he has other problems than I have. So, I mean, and we are basically in one European Union, so, and that's what we have to do there, is reconcile all these different opinions and also the different needs in the different countries. So we have to try to go from temporary measures to new standards. And I don't agree with that we have a good market. No, we don't have a good market. So let's have a discussion on that. We definitely need urgent market reforms. I will come back to that. I cannot give you any examples. But the way the market is functioning now is not taking into account renewables, the influx, the variability and so on, and also is from a very central point of view and is not adapted to any fluctuations. So, but I'm already going too far on that. We have limited possibilities as Belgium. Now I'm talking as Belgium. Also, it's said before. And I'm very glad because I worked very long for a gas unit in my ministry. We indeed seized that opportunity. There is 3 times the volume of gas passing through our country than what we use. So we're one of the biggest transit countries, not only in Europe but also even beyond that. So that's something we did good. And on electricity, I totally agree with you. But let's look at the future. So what have we done with the energy crisis? We have tried to be very strongly involved in European follow-up. We have tried to urge the Commission to come forward with ideas and so on. Like I said, we didn't always succeed. Because again, I can give you the examples of neighboring countries that have not always the same ideas as we have. Of course, the high prices is an issue. People say, well, you do like in France, you block the price and that's okay. But France is not Belgium. France has another adequacy. It's a lot of nuclear. Belgium is more diversified. It's also, we have another system like social tariffs and so on. So it doesn't work. And then people say, yeah, I don't understand what you're saying. Well, that's why I say, that's why I'm in the energy business, and we are trying to do our best. So I hope, and I'm very glad I can talk to you, I hope you will be part of the solution in the future. So we have no gas independence of Russia. We almost chose for Russia, because we have a gas company that has connections to the Russian gas in Germany, but we did not. We decided to diversify. We diversified already a long time ago. We have built one of the first LNG terminals in a time when LNG was, well, I think 4 or 5 times the price of gas pipeline. So from time to time you need to invest, but sometimes you don't invest right. But we didn't invest in Russian gas, so we don't have a dependence on Russian gas. Does that mean we don't have Russian gas? No, but I mean, I don't think I have to explain that to you, that in the end, because we are connected to so many other countries, Russian gas will flow through Belgium. But it's in the figures, we are not dependent of them. We have, like I said, a very strong network. Our government has decided that we continue with the nuclear shutdown. As you know, by 2025, all plants will be shut down. And then starting of winter 2026, excuse me, after 27, the two youngest plants will be restarted for a lifespan, well, let's say 10 years, but that can change. As you know, in Belgium, everything can change rather quickly. But for the moment, nuclear shutdown continues. It's not that we say now, no, we don't do that because we will need it. It goes on. We are trying to speed up and increase plans regarding input of renewables. Like I said, on our side, what I'm talking about, only offshore, because that's our competence. And then again, we have a very small sea, but I'll come back to that. So that's also why we believe in very strong interconnections, not only to our neighboring countries, but we are, and I'll come back to that, we are going to build an energy island in the North Sea where we connect even further than only the neighboring countries. For the moment, the crisis has no impact on further development of offshore wind. So if I set the scene for Belgium, what are we talking about? We are talking for the moment for the first zone, and I have some nice pictures after this, but just stay with me for a moment. We have a first offshore zone that is fully developed and working, connected. We had some problems like Ventilus. People tend to forget that, but even then we had problems to connect it onshore. I think now Ventilus will be okay in the end, one way or another. And again, I look at you. Maybe in the future you will invent that we can go underground and that we have the same possibilities we have now with all those high voltage lines. We are going to double the capacity by 2030. That's you might have heard of the Princess Elizabeth Zone. We are going to build one of the first energy islands in the North Sea, and you can hear maybe, but we are actually very proud about that, because we are one of the first to develop that. It's actually a very old idea. It's an idea, and I think you were already involved then, Dirk, in 2010, when we started building the first zone. We had the idea of building an island and an alpha and beta, it was, an island and a beta platform to connect onshore. But a long story short, some people went to my then minister who decided that we should not build the island. So now we are going to build the island. And we are not the only ones. Denmark is going to build an island also, Netherlands. So, I mean, this is the future, and we have set the wheels in motion, and we cannot go back to that. We are going for cohabitation. Before that, it was, you have that zone, and there you can build. No, of course, not in shipping lanes, of course, not in military zones. But now we started discussion with Greenpeace, WWF, BirdLife, and so on, because there is a large Natura 2000 zone, and we understand that we cannot invade that, but you can live together. And so that's why a lot of environmental studies are now going on to see how this new technology can go together with existing life, respect for one another. That's very important. Like I said, we have a very small, I think the coastline is 46 kilometers, to give you an idea. So we have a very small zone to build in, but we have neighbors with a lot of space. So that's why we now have MOUs signed with Denmark and UK on hybrid interconnection. And when we talk about hybrid interconnection, we mean that it's not only a point-to-point interconnector, but it's also connected to wind parks. And so that's in the two cases. Triton Link is to Denmark, and Nautilus is to UK. I've led PMI there. That means that's a project of mutual interest for the European Commission, but I used this slide for something else, so that I'm very sorry, I forgot to take it out. We of course cooperate with Netherlands, then Germany and Norway, because what we are trying to do is set a loop in the North Sea, either onshore or offshore, but so that we, in the end, we can have the companies build a very large network connecting all the countries and beyond that. And then our government has said that we have to build 8 gigawatts by 2040. I can already tell you now, we will not be able to build wind turbines for the moment, not be able to build wind turbines in the North Sea. So that's, again, why we look with other countries. Maybe we can build there, or they can build for us. And I mean, that's, I'm a lawyer, so I mean, that's my game. A little bit give and take and see where we end. So I know that it has to be correct for you, so sorry for that, but in the end we will get there. So a little bit what we did on cooperation, you might have heard that on the Esbjerg Declaration. Esbjerg is an old harbor in Denmark, but an old harbor that is now used by Vestas and Siemens. It's one of the largest manufacturer harbors. We came there together with Denmark, Germany, Netherlands, and Belgium, the 4 prime ministers. And the energy ministers, and we made a pledge there to have at least 150 gigawatts by 2050. And as you know, the European target is 300 gigawatts by 2050. So that says a lot. We also have something that's called North Seas Energy Cooperation, where we have Belgium, Germany, Denmark, France, Ireland, Luxembourg, Norway, Netherlands, Sweden, and the European Commission involved, and where we have made a pledge to have 93 gigawatts by 2040 and 260 by 2050. And I must say, ladies and gentlemen, this is without the UK. If you count the UK has made a pledge for 100 gigawatts by 2050. So that's what we are looking at. This is what we are looking at. We are currently pledging for 85% of the EU-wide ambition. And if we take UK back on board, then we go beyond that. But again, like I said in the beginning, a lot of talks, of course. We now have to start working on that. And so that's why we have something that's called Trans-European Networks, where we set out those targets. Those are political targets. Those were targets that set out by our ministers and the European Commission. We will sign. We are working currently on non-binding agreements with all these states that we will build that by 2050. I hope I'm still around to see that, but I don't know, we'll see. And so we now task N2E, with whom we work, that they look how to build this, how to connect dots, So it's also very important not only that we say, like for instance for Belgium, 2050, 8 gigawatts, but also that we say we are going to build it there and there. So we have to work together also with the environment to have the nice locations, and I will speed up. And we'll know that in 1 year. So this is to give you a little bit an idea of what is the pointer? Ah, I have it. So this is our neighboring country, Borssele. Unfortunately, you see, this is our first zone. Unfortunately, they didn't want to collaborate with us. This is a missed opportunity. But I must say, 5 years ago, the Netherlands had a government that didn't believe in offshore wind. And now they have speed up, and now, of course, they are sorry that we didn't work together because of SOR. Of course, you have here also the wake effect, but I leave that up to you to explain what a wake effect is. This is our new zone, the Princess Elizabeth zone, where we built here. We will build here an island. I'll come back to that in another slide, and where we also will connect to the other countries. So this gives you a little bit also a better overview. We already built an offshore switchyard in the first zone, but not all the parks are connected. Again, because of the minister I talked to you about that didn't believe in our plans for the island. And then now our minister does believe in the island, so we will build it. And it will all the new wind parks will be connected to that. I'm going very quickly now. This is Triton Link. This is connection we will make with Denmark. You see here the green line. It's just to give you an idea. It's 620 kilometers for the moment. It will be like this or like that. But we are also, and that's also why we had the Esberg Declaration, we are discussing with the Netherlands and with Germany to see where we can have some gains also, and also have other connections, because all you see, all this is to be developed wind parks. I have 2 more slides. This is with the United Kingdom, and this is where the wind parks will be built, and this is our Princess Elizabeth zone, to give you an idea. And this is, I don't know if you've seen this, but this is how possibly the energy island can look. So you have high walls because of the sea. It's some sort of caisson. Is that the right word, caisson? I know we use it a lot. Caisson, I don't know how to. It will be concrete, and with the substations, DC converters, you can see there a ship can land there. There's a helicopter platform. There's possibilities for innovation and so on. And I think that is my last slide. But I wanted to say, if you allow me, just a couple of things. Professor Dazeler mentioned the World Energy Outlook, and I agree that it's one of the best publications. We look forward every year. I've been looking in my mobile, but I'm not so good in looking into that. Our ministry organizes every year. We invite Fatih Birol, who is who used to be one of the writers of the World Energy Outlook, but is now the executive director of IEA, and he's a gifted speaker. So I will let you know. Because I forgot when it was, but I will find. So if you please, that's very useful to attend to. And then what I think is also very good literature for you is ENSO E and ENSO G. They will publish 1st of December their winter outlook, but they have already presented now preliminarily, because our ministers have asked that. They have already presented preliminary insights. Go and have a look at that also. It's also available on their website. And of course, on our website, you can find a lot of stuff on the islands also. And that's on interconnections. That's just to give you an idea, to give you a full overview. And that's me. Thank you. Sorry. Excuse me.
Thank you, Mr. Jan. So with this, we will proceed to a very short 5-minute break. We will meet again at 9:20 sharp, and then we'll have a debate moderated by Professor Dirk van Hertem.
Do you have questions from the audience? Questions from the audience. A lot of burning questions. Yes. But how do you do? So after the panel session, we were thinking to get those questions because. Okay, so you let me do some questions first, and then we get. Then I can read out the questions if you want. If you have any burning questions, can I have a look? Yes. So the questions are here. Yeah, I mean, this is. Yes. I tried to say this 5 times, but experience rebelled. The time was. Yeah. So these are the questions. Limited roads. Yeah. Christoph.
Hi.
Yeah, it doesn't matter what.
To grow and never end the energy crisis.
Yeah, might. I mean, I don't know. Like, how long was it supposed to be? Like the total event?
Pay for the investment assessment.
Until then?
And then there is this one and this one. Yeah, no, not the idea will probably come back. But it's, I mean, for 5 minutes, it's going to be 10. You cannot have a 5-minute break. I mean, it doesn't exist. I mean, if I teach and I have a 5-minute break, which takes less than 10 minutes, I'm always very happy. So, how many questions would you take? Because there are, like this here, at this university they have developed a production of hydrogen. Okay, yeah. Hi. How are you, Helming?
Yeah, good.
Good to see you, man.
Actually, I'm going to leave because I need to do some other things, but I will follow the live stream.
Alright, good.
Thank you for organizing this.
So basically, emerging technologies, how are emerging technologies being taken into account in this energy transition?
And then the final question is, I think the lesson learned from the Ukraine-Russia conflict for European.
Economies.
Is hij het laatste slide? Het is misschien wel goed om het... Okay, just a second.
Yeah, that's it.
Okay.
Ja, dat is beter.
Deze.
Dat is beter.
We gaan wel proberen om kortere panelgesprek te hebben en meer to the point. Want ik denk niet dat er iemand zich aan de 15 minuten heeft gehouden.
Nee, ik denk het ook niet.
Dat is oké. Ik had het eigenlijk ook niet verwacht. Maar dus, dat is oké. Ja, dan mag
ik moet zeggen, met dat ik taalsleraar aan bezig was, dan dacht ik van, tja, ja, daar kan ik ook iets op zeggen. En dan François dacht ik, allee jongen, kijk, een goede markt, waar halen dan nu?
De markt, het principe is goed, het probleem is de liquiditeit van de markt. Was er niet. Het principe is goed, maar je hebt een aantal voorwaarden die niet aan voldaan zijn. En dat is het probleem. Maar dat is niet het design, maar het is goed voor langzame veranderingen. Het is niet goed voor sudden changes. En dat merken we nu. En er is ook een verschil tussen long-term en short-term, wat we altijd al gehad hebben. Maar dat wordt nu, door die boost, wordt er eigenlijk wordt dat heel erg pertinent. Ja, dat is eigenlijk het. Op zich is er aan de markt niks, want die krijgen de juiste signalen. Maar het duurt 10 jaar dat je geïmplementeerd is. En dat maakt niet uit voor de energiemarkt. Maar ondertussen hebben we wel een paar mensen die doodgaan van de kou. En dat is dan het probleem. Ja, in een economie is dat, hoort erbij.
Maar het is dat wat ik ook zeg, als ik zo naast die een Bulgaar zit, ja, die heeft al alle problemen als ik heb. Hè. Allee, ik bedoel,
Die zegt van, ja, dat kan allemaal wel schoon zijn dat je veel moet betalen, maar bij ons betaalt niemand. En dat betaalt dan niemand.
Nee, en dan zeg ik tegen die zij soms, ja, het is een iets oudere mens, die zegt dan tegen mij, oh, waren de communisten er nog maar, dan moesten we iets betalen. En iedereen had een job en iedereen had verwarming. Ja.
Maar was beter? Dat denk je goed?
Denk het ook, maar alleen.
Let's, because otherwise people are
Deze aan jullie geven. This one is for the three of you.
Ja. Okay. I don't know whether this one is working. I think so. Yes. Okay. Thank you all for coming back, which is always something we hope for and very much appreciated. I think we had a lot of very interesting discussions. We weren't able to keep the time as of yet. We will potentially be slightly delayed in the end of this, but we will definitely stop before 10 o'clock. So I would like to start off the question, and this has been addressed a little bit also by Peter, and I think this is a thing that we get often is, this energy net zero thing is mainly focused on the power sector, but if we look at it, it's just 20% of the whole. So maybe we can go around and see how we can, why is this the case, and what can we do to also do the other 80%? Is someone willing to start off? I see Francois, yeah, maybe William. And in order to make sure that we keep the time, rather short questions and answers.
Okay. I think the reason why we started with the electric power sector because it's the easiest sector. It's the easiest sector to mess up because that's basically what we're doing. We're now actually perturbing the electric power sector like hell, but it's going to be successful and indeed it will start to make a difference. Now today, in this early afternoon, I attended a meeting of the Belgian Academy, the Royal Academy, and they had a study that they presented. There were basically two Dutch people who were assisting or helping then the Belgians on the building sector. Now that's going to be the crisis sector in Belgium, to reduce the CO2 in the building sector. It has to do also with the spread of the housing and transportation, etc. Now, transportation is going to be helped to a large extent by electrification, which is kind of successful. But the heating sector in Belgium, when you start touching the people, their homes, their houses, there's no politician in Belgium who dares to touch them, because otherwise people will react in the voting booth. And we see that at this moment, politicians are afraid of taking hard decisions, and that's what I'm mostly afraid of, to be honest.
So maybe Jan, you can respond to that, because you give advice to politicians on how to tame people. And
yeah, I give advice, but they don't always follow that. So that's to be quite. Oh no, it's recorded. Shit. No problem. But I do agree with Professor Dazeler. I think we have started with something that we thought was easy. But in the end was not easy because we don't have the solution yet. So I'm indeed very much afraid for the rest. It's for years, and I already told that I'm a lawyer. It's for years that I'm trying to convince, and I've seen a lot of ministers already. I'm trying to convince minister to go a little bit against the will of the people.
Okay. Anyone else who wants to pitch in? Yes.
Security of supply.
N minus 1.
Lack of electrical engineers.
Okay, and now? Is it better? No? Yes? Okay. Yeah, well, okay. No, I fully agree. I mean, power sector looks easy at the first glance. You say, well, fair enough. I have a PV and wind farm, wonderful. I can just replace it. It's easy and straightforward. And some people just claim we just change it overnight. Actually, that's where engineers are important, because you can look at a couple of figures and you see that, oh, shit, there is still a gap. And that's why we still see all those fossil fuels. And indeed, for the other sector, transport, you are touching upon the car of people. You know, cars are important for people. That's something very personal. Houses, building, the house is also something extremely personal. The heavy industry, it's also something very far, so politicians will not spend too much time on that. You also have agriculture, and then people think, oh, that's not something we want to touch upon. So that's why the focus, in my view, was first power. Looks easy, it's far from people. And actually, if we want to go for net zero, we need to have all sectors.
Okay. Maybe. Peter, you already commented on it, and as the cable is short and we're searching... okay.
It was fine.
No, you wanted to add something?
Yeah, I think I agree. The built environment, the residential homes, that will be a big problem, and the policies are not where they should be. And the longer we wait to put adequate policy framework in place, the more it will hurt. A few examples from industry, that's also a hard part, but then more from a technical part, I think. For example, in the mineral non-metal sector, purification of sand, for example, they use a lot of gas burners that directly, the flame gets directly in contact with the sand. And that's the cement sector. You have emissions, feedstock emissions, so you need carbon capture. And non-ferrous sector, for example, metal recycling, also need direct contact with the gas flame. It's not even sure if hydrogen will work because the flame structure is different. That's from a technical perspective, a few transformations that will be hard, and I look to the engineers to solve this.
Okay, we engineers have lots of things to do. That's actually job security will not be a problem. I will get back to that later on. But something you said got my attention, and that's industry. And very recently, there was a buzz about decarbonizing the industry sector. And why is that? Because they all got a scare from the Ukraine crisis, and then they decided to go carbon neutral in the next 10 years. Also the large industries like BASF in Antwerp, Sitmar is planning to triple its consumption in the next 10 years electrically. So that kind of a transition is happening, let's say, given through the crisis. Do you see that this is something that we will be able to manage, or do you foresee that there are some issues there? Anyone who wants to, because just some things that are being mentioned are supply chain issues, or who is going to do it. Again, job security is not going to be a major issue in my opinion. So anyone wants to?
Well, as far as industry is concerned, the way I see it is that you will see many things in parallel. First of all, you will see displacement. So the question is, here in Europe, and in particular Belgium, are we going to be able to keep the big industries here for the next 20, 30 years or something like that? We had an example yesterday, I think, or was it this morning in the TED, Solvay, big announcement that they're going to try to decarbonize here their process, but they're going to invest massively in the US somewhere. That's the first thing. The second thing, I think industry has understood that they will have to electrify. It won't be easy, but I think they have the direction now. I think what industry wants is to see the direction. I think they now think that the shock that we're going through now is going to also help the politicians to set out a straight line so that they know when they invest that it will probably be irreversible. What I also think that industry will do, and that will also get a boost, although we have a natural gas problem, but that will resolve itself a little bit, I think, over the near future. That's carbon capture, utilization, and storage. I think we probably will need that as a transition. What it will be then in 2050, who knows? It's everybody's guess.
When we look at our energy system model results, we see with 16 gigawatt of offshore wind, the system cost and also the electricity cost is much lower. So ideally, we would get that amount of offshore wind in Belgium, but there's no master plan ready to get this amount of electrons into Belgium yet. And ideally, this is still a constraint we put to the model. So ideally, it would even be more. And for that, there is not. So we have work to do on planning. Companies are moving, but there is work to do on planning how to get the electrons into the continent and the molecules into the continent.
And European infrastructure.
And finally, there is also a large chance that industries, energy-intensive industries, will disappear. And this is something no policymaker wants to talk about or want to think about. And these are a type of questions that we, as research institutes, need to answer in the coming years.
François, is ENGIE ready to deliver 3 times the amount of energy to consumers throughout? Because that would require likely more generation plants to be built. For a company in transition, this might be an interesting challenge as well.
Yeah, well, if you remember some graphs that Peter showed, you see the electrification. And if we get rid of coal, of gas, of oil, that's an enormous potential for development in renewables. And we often say efficiency, renewables, and then what you cannot electrify, go ahead with some green gases, green H2. And we see here enormous opportunities. That's also why now companies such as ENGIE, but to be honest, a lot of utilities are following the same trend, investing massively in renewables. And when you mention this 16 gigawatt of renewables, then definitely you will see plenty of players all over the world willing to invest in this. And to give you an order of magnitude, as ENGIE, worldwide, we invest between 3 and 4 gigawatts of new renewables every single year, and we want to go even more, 5 or 6 gigawatts. And this is what we are doing. But actually, when you think of this figure, it's extremely small. I mean, we sometimes have the feeling that ENGIE is enormous in Belgium. It's true that we are a big player in Belgium, but worldwide, you need plenty of companies as big as we, and especially because you need a lot of money. I mean, this is a lot of capex investment, and you need the skills. So again, you guys are likely to get a job. I'm very happy for you. But you also need all the materials. You need to be able to deliver all of this. And last but not least, we are a university. If you look at the IEEE report, there's something extremely interesting in this, which shows that a lot of technology we need to decarbonize, all type of sector, industry included, are yet still to be developed. They are in the lab, they need to go to pilot, and then to industry. And that's something which will take time, and there is a lot of uncertainty around that.
Very good. Jan, maybe you can comment whether the government is discussing with the industry to be ready to decarbonize. I know there are some discussions also on the offshore sector. There are some challenges there, I guess.
Yeah. Because you know a little bit politicians. I don't have to tell you, and also you all have had to do with politicians. I hope in the future, in your future life, you don't have to do too much with politicians, but you always have to convince them. And so also tell them also, when you come, again, when I tell them 2058 gigawatts, but that means shorter delays for permitting. You need all the material to be there. You need the right people, not only to manufacture it, but also to build it. You need the right people to transport it, to maintain it. So, and that's what we have. When I talked about the Dublin statement, that we invited people from the industry, telling that exactly to ministers, to put them together in one room with ministers and the European Commission. It's all very good and very wise to have that switch to renewables, but all the rest has to follow. And that's, like I said, the time is too long for the moment. And also, there's not enough material. If you see for the wires and for Ventilus, Elia now has to go to Greece. And I think Greece will not produce enough, so it will come from Taiwan in the end, which is all very good because we are living in one world for a moment. But it has an effect on costs and on everything that follows. There's a value chain that we now have to put on front of it, and we have not done that so far. And that's what we try to tell politicians now. Look at this. We need that value chain. And then, and sorry, I'm again talking too long, but what we see is that a lot of companies now already work together. And to give you one example, we are very strong in shipping business. So we have two big companies that didn't talk to each other. They're now talking to each other, and I can tell you they are talking to a third large shipping company from the Netherlands. So they are now even sitting together and seeing where their ships can go and how they can work together. And that's in the end what we need to do, and also what we need to say to politicians, so that we can take that into account and that all the plans and the idea can become a little bit more realistic.
Okay. So I'm happy to ask questions until 10 o'clock, but we also have an audience, so maybe there is a question from the audience.
Let me just follow up one thing.
Think about that question, and then after the response from
that's
Jan.
for the colleagues and also for Dirk. Because I think it was Peter then who made me think of it. Getting then that electricity, I think the generation of electricity will not be too much of an issue, but getting it to the industry. Permitting. How are we going to resolve that? Are we just have to, will compensation be enough, just paying people? Or is there some structure that we can think of? Because it seems to be a problem everywhere.
Maybe, Peter, you can say what we had a phone call about this morning, the discussion that we try to solve this exact issue. Do you want to talk about it? Or?
Yeah, it's as I said, we don't have a master plan ready. We need a complete redesign to rethink how we transport electrons and molecules across the continent, and analysis is still happening in a too fragmented way. So I think there's a lot of work to do there. That's basically the short version.
Just to give you a small idea, these very big towers that we see currently have 2 times 1.5 gigawatt. We're upgrading them to 2 times 3 gigawatt. And these guys are talking about 200 gigawatts that we'll have in the future. Not necessarily over one corridor, but the scale, I mean, if you think about how many 1.5 gigawatt lines you need to transport to 200 gigawatt, then you know that Ventilus of 60 kilometers next to a highway, it's only an indication how much pain we're going to have in the next years. And I will not talk about Ventilus anymore, and I suggest that we go for a question. You can. I will repeat your question for the people online. So, yeah.
So, first of all, thank you for the presentations. However, I see a problem. We have a super European. You're speaking about Africa is not there, even if energy output is perfect, but still when you go to the African part, not acceptable at all. So first we are speaking about another part of the world, lots of impact on the life in Europe, but more than that, how things are going on in other parts of the world will impact Europe at the same time. We are seeing the Russia situation. Basically, we were in this energy crisis for a long time, feeding Russia to buy more VPN, doing this with Saudi Arabia, just because we needed them. However, we knew that something like this may happen. This is the same. Now we solved the problem with Russia, but we don't know who is the next one. So I want to understand how energy models, how the models, and more importantly, how politicians are looking into how we are assuring that there will be no after 10 making the same problem. Are we seeing that?
Okay. So just summarizing the question for those that are online. So the question is, most of the models focus on the European context, but there are other continents which have a very high importance on how the European energy situation is. Africa was mentioned, Middle East, and of course Russia, which we failed to model correctly. So how do modelers, or in general the energy sector, deal with these situations? And I guess mainly the uncertainty that comes from those regions. Anyone? Because this is maybe Jan starts and then we go this direction.
I'm not a politician, but I do feel with you. What I tend to, and again, this is recorded, so, but okay. When I discuss, I think it's very, very bad what happens in Ukraine, and I think the guy should be punished and whatever and whatnot. But as you can see, I'm a little bit older. We have our so-called American friends who have done similar things in other countries also. And we have never said anything about that. And there's a lot of stuff going on in a lot of countries where we don't say anything about. And this is my left-wing political ideas that are talking now, so that's really personal. What is the problem is that we are staring at our belly button for the moment, and that we, like for instance, we have been talking about hydrogen. But Oman, we can do something with Oman on hydrogen. We can do something with Namibia on hydrogen. We can do something with Egypt on hydrogen. And then they asked my minister, but there's a dictator in Egypt. But that's not a problem. Eh? We are helping the population also. So we are not there yet. I'm very sorry to say. And I know I started with a quote from Winston Churchill, but we are very, very far away from that. And I hope, I sincerely hope that your generation will do better than we will on that. And that's because that's really, really an issue.
Okay. From a modeler's perspective, Peter, you want to?
Thank you for this very, very relevant comment. I think my and our colleagues are at the time in Ghana to support the people there. We do a lot of projects in Africa also, where we support them to build data, because in many African countries they have to submit climate plans, but there's no data. People heat themselves and cook with what they find. There's no data collection. It's very hard, and those member states, those countries have very different problems than we have. And so access to electricity, access to food. I think the way we need to go about this is first exporting our technology at favorable terms. And then secondly, I would like to come back also what Jan said. Do not learn from the mistakes we've made in the past. Indeed, we are looking at first import hydrogen via shipping from Namibia and so on. First of all, a lot of it via ship will not be commercially viable in the next years. That's problem number one. So politicians are not always guided by the techno-economic result. And for example, in the first version of the big hydrogen backbone that was put forward, a lot of hydrogen, green hydrogen, was coming from Ukraine and imported in the EU. So even more recently, we are making similar mistakes. In the CIREC project, we work together between Energyville and the University of Ghent, where the University of Ghent, the group of Thijs van de Graaf, performs a geopolitical assessment of a country and of the structure. And I think we really have to take this into account if we import in Europe or we have energy relations. How diversified can the market be? How can we also teach and assist, facilitate development in developing countries without exploiting them? I think there's also a lot of research to do there.
Okay, I'm not sure what I have to say about that, but let me first of all say that when you're referring to the IEEE and the World Energy Outlook, as a matter of fact, not too long ago, they had a special issue on Africa. So they do address these issues, and I think over the last 5 to 10 years, the accessibility or the access in Africa has improved. Now, what is now happening with that crisis in Europe and the worldwide crisis, that indeed then because of that and the higher costs, that the accessibility is going down again, the access is going down again, and that's too bad. I think the solution in the end will have to come from technology. I hope that technology will become cheaper, and that then that technology can be rolled out also in all kind of countries, including then also then the emerging countries. There's of course in many of these countries, and it's also in Europe and it's everywhere, you have the political game and also then the geopolitical aspects. And it's not always, and I have to be careful when I say about Africa because I'm not from Africa. There is also, it's not always coming to the right people. I'm not necessarily wanting to use the word corruption, but there is actually quite a bit of that. It's not easy. I think we will have to, if for instance, if the hydrogen issue was mentioned and then transporting from there, you always have to have a fair game. In the sense, of course, and that's the same thing with issues with oil and with gas, okay, if they have the resources, okay, but they need technology also then to develop the resources or to harvest the thing. So there needs to be a fair game because an investor also needs at some moment some money. Now I'm going to say one more thing. There was at some moment I was asked to that makes things actually complicated. That I was asked to moderate a session on Africa with a colleague, an elder colleague, Professor Palumo, I don't know exactly what his name was, from Kenya. Okay, and that was at the moment when the oil prices were relatively low. He was making a problem of the fact that the oil prices were way too low because, of course, his country is a big oil producer. But there's so many countries in Africa that are oil consumers. For them, of course, the oil prices were still too expensive. So I'm just saying that even when you talk about Africa, Africa is not just one thing. You have different issues. You have to look at these things differently. In the whole modeling that we all do, or that some of us do, the human factor is always the very big unknown. It's on the level of the consumer, it's on the level of the investor, and it's on the level of the politicians. And that's what always makes it difficult. But we should never give up, never throw our hands in the air, but always try to do the best that we can and try to do it in a fair way.
You wanted to, well then, and just picking up two things, I as a chair, I can do whatever I want. I didn't discuss that with these big disruptive events are the most difficult thing to model regardless. And we effectively shown that 3 or 4 times in the last 5 years that we couldn't. Yeah? And the result is not necessarily better modeling, but more resilient approaches that are able to deal with whatever curveball comes and are less sensitive to single in-feed stories. So that's a general thing which doesn't help you, but immediately. But if you do some modeling, resilience is probably, and you will not be able to forecast. Otherwise, you wouldn't be here, but you would earn lots of money on the stock market, where they also effectively fail to predict the crash. Some of them, the one that doesn't, he owns an island somewhere. Very quickly, but in the meantime, there was a question.
Very quickly, sorry for that. Very quickly, we now have to. We are also doing risk plans on electricity and gas, and we have to take into account the last 5 years. So we now are discussing with the European Commission that we do not take into account the last winter because it's not a normal year, and that's very difficult because this is a crisis.
We don't know. Maybe the next 5 years will be the same.
It might be. But this is a crisis. This is not a normal situation. So that's basically, it's very difficult. Sorry.
Jesus, you had a question. Three, one. No, maybe 2, but not 3. Okay. Okay. Okay, so there are several questions in these 3. The first one is basically how inefficient are we today? And maybe the TSO is a small example, but everyone knows that at some buildings in this university, best temperature regulation is to open the window, even in winter. That's so how inefficient are we, and where are the quick gains in that? And the last question I'll pick into, should it be our ambition to be an industrial center because we can be a knowledge center and we can be, let's say, and this is going to be very politically tainted, the Hong Kong of the North Sea. I think someone else has said that before, but very recently, a nearby country. But is that something that we should move in that direction? I don't know who wants to start with that. Maybe you mentioned something on energy efficiency first, so maybe you can. What don't we do well today that is a quick gain?
I will react on the third point on the industrial center versus a research center. I must say, if you ask an economist about reactive power in front of engineers very quickly, it's going to be funny for you guys. So I will not be very helpful there. But in terms of industrial center and research center or knowledge center, I would just give you a personal view. I mean, if we want to decarbonize our economy, we need massive investment. I hardly believe that there will be countries where we have no infrastructure. We will need some infrastructure, we'll need some investment. And if you decide as a country to have very limited or no industry at all, you would have to import all of this. So it's a bit like the diversification we have been talking about. And I don't want to be an advisor to policymakers, but in this case, having a mix of industry and research center, because the other way around is also true. If you say, well, research, you have all those PhD people doing stuff which are useless, let's get rid of this. We will buy the technology and the research from Harvard and other university. I don't think it works either. So I think it's a good policy here is really a mix of the two. And also as researcher, my experience working in the industry, it's very fruitful when you collaborate on real stuff. I mean, a lot of researchers like to work on equation, but a lot of them also like to work on real stuff. I see that you will be visiting your power plant at some point. You may visit other stuff. A lot of engineers, but also I would argue economists, policymakers should go to the real world, see the real stuff, see how an interconnection is, how a power plant is, what are the difficulties. And I think it's important to have the mix of the two. So I would argue that you need the two. The share of industry in your GDP, whatsoever, that's another discussion. But I would argue you need it anyway. Okay. Who wants to take reactive power?
I think it's more energy efficiency in the system, I guess, as a more general, where can we, did you have your simulations show any places where we should immediately increase efficiency, or you modeled things at the efficiency which is completely different than the one that we have today?
There are efficiency gains possible, for example, in industry, but the largest gains have been made already due to the. If you look at the energy intensity per product in the industry in the 90s, and if you look at it now, there are already quite large efficiency gains. And the most efficiency gains that will happen are hand in hand with electrification. Of course, heat pumps and electromotors are 2.5 times, electric vehicles 2.5 times more efficient than fossil fuel vehicle. Heat pumps, but also in industry, electrification will be more efficient than burning fuels. Should we become the knowledge center, I think there's a possibility that base industry, for example, ammonia production, why should we produce it in Europe from gas when you can produce green ammonia worldwide and import it? But it's never that simple. For example, if you look to the chemical industry here, ammonia, from ammonia they make fertilizer, from natural gas they make ammonia, but processes are exothermic. So if you import the ammonia instead, you need to find another heat source. And the chemical industry is saying, what happens to my site? I just calculated it to be optimal, and now you're taking out parts that shouldn't be taken out. So it's the human capital is also very important. Bulk processes can be maybe displaced to places with high renewable potential, but also the human capital, if you have all the products we produce in the chemical sector, these expertise, it's really hard to export this. So there's an option that the technology-related industry is mostly remaining here, and the really energy-intensive is moving out. That's a distinct possibility.
Okay, allow me to be a bit provocative, okay? Some of you wouldn't have expected otherwise, but let me discuss the issue of efficiency. Actually, you should wonder, why is efficiency so important? Now, efficiency is something, at least in my mind, is a transitional thing for the next 10, 20, 30 years. And why is that? Because in thermodynamics, we've always learned technical efficiency has to do with the fact that you need a fuel, you have to convert it to something useful, and that's your technical efficiency. Now, we're moving to a world which is basically mostly, PV, solar, wind. Okay, I know that for batteries you also have particular efficiency, but I think we have to look at what is wrong with something, or if you have all renewable energy generation locally, that you produce a little bit more energy than somebody else. Who cares? As long as it is clean. But that means that when I'm saying that, you have to take into account the energy efficiency together with material use. So you have to incorporate the efficiency of your resource itself. That's why I define this thing as resource efficiency. That's the whole thing, which then quite easily is translated into economic efficiency. And so in the end, it all comes down to the cost to economic efficiency. But necessarily, and of course, for the next so many years, we can gain by insulating and what have you and all these things. But if you have enough local production, or if it comes quite cheaply to you, electricity that is generated, who cares whether you use it? And the same thing, that's the whole issue that here in Europe seems like many people are afraid of air conditioning. Okay, I would say, well, okay, go a little bit to the south of Europe. Sometimes I feel sorry for the people that they don't have air conditioning, because actually with more air conditioning they could be much, much, much more productive. If you then, the point is of course that you have to make sure that your electricity has to be produced in a clean way. Now what I have at home now, and I'm going to tell a little secret, I have, we wanted to, because of these very hot summers, we wanted to install air conditioning. Oh, and then we said, although it's reasonably well insulated, but we still needed air conditioning. And then we said, yeah, but now we're going to put then also enough PV on our roof. So we've over-dimensioned a little bit the PV we have on our roof. And as a luxury thing, I'm reversing actually the air conditioner as a heat pump in the winter. And so at this moment, we're heating our home with heat pumps. Isn't that a nice story? What's wrong with that? There's nothing, I don't blow any CO2 into the air. Unless, of course, you could say that the panels, the solar panels, that they were produced somewhere where indeed then coal was burned. But okay.
Well, a very short answer to the comment from William, because we have one more very short question and then we go for the reception. So I'm just
Well, actually, you are an illustration of the famous paradox of Jevons. Maybe you have heard of it, but it's more something like 200 years ago. It has to do with the rebound effect. Actually, some economists at some point look at the coal utilization and technical progress. And they had in mind at that time, it was in the UK, that with technological progress, we will use less and less coal. And actually, they realize that we use more and more coal. And what you are just illustrating, indeed, you install PV, you say, wow, that's good for the planet, we will reduce CO2 emission and utilization on gas and coal. And actually, what people do, they install air conditioning or they heat their swimming pool. And this will,
That's a different thing.
this would be, this, but this would be okay, indeed, if the whole system will be decarbonized. But the electricity you are using for air conditioning, I'm not blaming you. I have colleagues doing it. And I have my wife on my back saying we should do that. So I fully understand. However, from a system perspective, you could argue that this electricity you use for air conditioning would be better off into the system to use less gas somewhere else.
But that's a temporary thing. That's for the next 10, 20, 30 years. By 2050, we should be carbon neutral.
Exactly, but for
So
the 20...
2050,
I think we'll have many discussions during the reception afterwards as well, but I wanted to end with one question that came from the audience that is not physically here, and I summarized a little bit. And I just want one word or one sentence as a end, because I promised to end not later than 10, which I failed at. So we already have a lot of new technologies in place. We have LED lights, which we didn't have 10, 15 years ago, which changed a lot of how we do things. Electric vehicles are coming. We'll have only electric vehicles sold in Europe by 2035, Belgium, Flanders even 2029. Heat pumps are there. What are the emerging technologies, or the emerging technology, or in your case, Jan, the emerging policy that will help us in getting towards 2050 in a net carbon society? Who wants to start with that? Or what do you think will make the difference? What is the number one priority that we should think of?
I will disappoint you. None of them individually.
Okay. So combined effort.
So we need all type of solution on the supply side, heat pump, vehicles, whatsoever. On the demand side, I mean, if you renovate building, and double glazing insulation is low tech. You know, just we have to deploy such a thing. You can think of new technology, batteries, hydrogen, all type of things, and also policies that make sense. And also stupid stuff like. I mean, you cannot bike in many places. If you cannot, I mean, I've been going to my work in Germany and in the Netherlands by bike for 8 years. I live in Brussels since 15 years. I still cannot bike, and I live 4 kilometers from my office. Just basic infrastructure. I mean, cycling is easy, but if you do it in Brussels, you just die. So I'm not doing it for now.
I agree with what you said, and you mentioned 2050. We've been talking about 2050, but 2030, this is my worry, that policies, and even if we mean well, it will be too late to get to the 2030 targets, and what happens then? Did we already give it a good thought? What happens with all the climate policy, with the whole the ETS system, if we miss the 2030?
When we miss.
Targets, yes. And it is worrying because you want to bring positive messages as energy researchers, and towards 2050, it's not by a single bullet, but I'm convinced I'm retiring in 2050. And I'm my end speech, I can say, we did it, this climate policy, but 2030, that will be a different story.
Yeah.
One sentence. First.
All of the above. All of the above.
All of the
No, it's. I'm actually more optimistic. And look, I'm going to be very straightforward. This type of circus that we have seen with several 10,000 people in Egypt, stop it. Okay? I'm a strong believer in technology. And I think what we have had the last 3-4 years, so these shocks, they will help the whole thing because people will realize that now it's becoming serious. And I think that we will see a difference up to from now to 2030. I think technology will be faster than the political world, etc., and they will have to follow at some moment. I think we need all of them together, and I hope for an environment in the sense that a competitive environment, that the technologies can compete with each other, and I hope that the best may win.
Okay. Yeah, Jan, you wanted to give the one single policy advice that will change the world before we can go to the reception.
I can only add, and indeed I agree, it's not the one size fits all. It's not the one solution. You have to see it together, and that's also what we are now investigating, what we can do, not only offshore, but also if you can, for instance, floating solar panels and so on. Even flying now, we have a test zone where they have flying turbines actually. So that's all very good, and we are very supportive in that. But I'm also, and I said that also in my presentation. We cannot do this alone. We have to do this with the other countries. So cross-border aspect is very, very, very important in all this.
Okay. With that, there's one more thing that we need to do, and that is thank our excellent presenters of today and for the excellent debate as well. So thank you very much.